All right, example 5. So we have a steel ball that strikes a wall. Our system here will be the ball. The environment's going to be the wall. Our initial picture is given to the left, and our final diagram is given to the left. So we know that the wall is going to exert a force on the ball that's directed to the left. So in order to figure out the force of the wall on the ball, all right, we're going to have to look at the momentum of the ball initially that is directed at the wall. So since the force is exerted to the left, that means the only velocity that's going to be affected is the horizontal velocity relative to the picture. So the momentum here, we're going to be going in the x direction. So we're going to look at the momentum initially in the x direction and the momentum final in the x direction. So initially we have momentum going to the right. We'll call that the positive direction. Then when it reflects and bounces off, since we're only looking at the ball, it is then headed to the left in the negative direction. Now, the mass and the velocity do not change, which means the amount of initial momentum and final momentum do not change. However, in order to stop the ball and cause it to go with the same momentum in the opposite direction, you have to have twice the amount of momentum directed to the left than you did traveling initially to the right. So the impulse is going to be a -4 bar. So if we're doing this conceptually, we have +2 momentum, then we have -2 momentum. So in order to stop that momentum from going to the right and cause the same amount to go to the left, conceptually the impulse bar is going to be twice the length. So to figure out this momentum initially going to the right, we're going to have the mass. So 3 kg times 10 meters per second. However, the only velocity affected there is going to be the velocity moving to the right. So we're going to have to multiply this by a sine of 60. Given our diagram, 60 is right here, so we need the horizontal component, which will make it sine. So when we multiply all this information out, we get 30 kg/ms times 0.866, or this would be 26 kilograms times meters per second. So when we look at this, we then have our initial momentum then reflected off going to the left is going to be -26. So we have initially 26 kg/ms minus our force of the wall on the ball times our change in time will equal the final momentum, which is -26 kg/ms. So to figure out the force of the wall on the ball, we know the time here is 0.2 seconds. So we are going to have the wall on the ball times 0.2 seconds is equal to -52, or excuse me, the negative force of the wall on the ball is equal to -52 kg/ms. Divide both sides by